Hello children of class 10th, welcome to another session of chemistry only on Classroom TV. I hope you are doing well and enjoying classes during COVID times and going through all the content only on Classroom TV. So let's start our class. Like in our last class we have done with the chapter structure of atom. So basically like in your earlier classes you already learned that atom consists of subatomic particles, protons, electrons, neutrons, and the different theories which were been put forward by different scientists, the atomic theories which have been developed. And at last when we have come to a conclusion where Niels Bohr was successful in explaining the structure of an atom, where he was trying to explain the stability by introducing the concept of energy levels. And during which we find like each and energy level is associated with some sort of electrons which are revolving around the nucleus in circular paths called as orbits, or which we also say as shells. So when we are trying to differentiate between orbits and orbitals, so orbits are those main energy shells where the number of electrons are present in those orbits, and the designation, the number of electrons per a particular energy level which designates or holds, gives you the representation of those orbitals which we give as SPDF, or representation of those orbitals. So in that way we have done with the chapter. And next coming to the last part of our chapter, where we try to find like how this atom, when it's been stable, where the different elements, when they try to lose or gain electrons in order to be stable, because the most important criteria or the condition during which each and every electron, that's nothing but an atom, try to be stable either by losing the electrons or gaining the electrons. So during which the losing and gaining of electrons makes an atom to be stable, and during which we can find the set of atoms together will form a molecule. So here we are trying to find like this group of atoms whichever are held together, or which is responsible, means what kind of forces are involved which makes these atoms to hold together to form a molecule. For example, when we say water molecule, so basically when we say water molecule, so during which you know very well that water molecule consists of hydrogen atoms and oxygen atoms. So what kind of forces are responsible which makes or which allows the hydrogen atoms and oxygen atoms to hold together or bind together or bond together? That concept we are going to learn in our next chapter, called as chemical bonding. The word itself, chemical bonding, means each and every elements of those atoms, because this group of atoms or this group of ions in turn form molecules. So when this group of atoms and this group of ions, when in turn when they form molecules, so definitely we find there are some forces which are allowing, or because as already you know, like whenever we would want to sort of do any of the work, we find there should be a force which involves or which tries to bind or which tries to hold or try to pressurize those things. So in this case also we find whatever the molecules whichever are formed, which we call as chemical compounds, or those chemical molecules, or any of the new compounds or new substances, whenever they form with the group of atoms, because this group of atoms in turn gives a molecule. So all this group of atoms or those ions gets associated with some kind of a bond which helps or which hold these atoms together with some strong attractive forces, which we call as chemical bonding. Means this chemical bond will give us the overall transfer of electrons. Means in such cases only we are going to find like what the electrons are losing are they losing the electrons, are they gaining the electrons. That concept of losing or gaining of electrons is well explained depending upon the number of available electrons which try to be stable either by losing it or either by gaining it and try to form a bond between them, and that particular bond we call as chemical bonding. So in this chapter we are going to learn like what kind of bonds gets associated when a molecule is formed, when this group of atoms and ions, when they are grouped together in form of a cluster, or when they get joined together, or when they get bond together, what kind of molecules gets associated with this and what kind of bonding it wants to that also we are going to learn here. Apart from that, here we are going to learn some different theories like valence bond theory, valence shell electron pair repulsion theory, which we call as Vesper theory, concept of hybridization, and even already which familiar with the basic two types of bonds which we call as ionic bond and covalent bond. So basically, you know, like covalent bonds in our chapter periodic classification of elements also we have learnt that the mutual sharing of electron, or just we say sharing of electron, leads to covalent bond formation. Then the same way ionic bond is transfer of electrons. So transfer of electron leads to ionic bond formation. So in all such cases, we are trying to find like each and every whatever atoms, when they get associated or when they coordinate to form a molecule, there exists a bond between those atoms which make them to hold together or bond together or bind together, and that kind of bonds we are going to learn in this chapter. So basically, first we are going to start with the introduction, and we are going to learn the concept of Lewis dot structures in our first session. So let's start with the introduction and Lewis dot structures. So let's start with the introduction, and we'll basically go with first what are these Lewis dot structures. Yes. So first, as we know from our chapter itself, when we were learning periodic table, we find all the existing 118 elements. So these 118 elements whichever existing in our periodic table has gave us an idea where we were trying to predict those elements as per their some of the physical and chemical properties. Because of this some physical and chemical properties which made each and every elements whichever we have been learning, which we have been arranged in the form of the groups and periods, isn't it? So during which, like, because this particular table has helped in predicting the type of bonding, because as we are going to learn like which kind of an elements are associated or grouped together or which helps in bonding will take place between atoms of those elements. So here they are nothing but the ions are positively or negatively charged particles. So basically, you know, like the ions like metals, and we have non-metals basically. So you know, like basically the metals whichever we found in our periodic table, which have been found to be in our S block elements, which are your 1A and 2A group elements. And then the next one, like when you go for non-metals, which we basically find the non-metals mostly found to be in our P block elements. So generally those are nothing but those elements whichever we grouped up are trying to identify or trying to classify those ions as positively charged particles called cations and negatively charged particles called anions. So in such cases we know very well like metals are found to be the positively charged particles, or which we say as positively ions. So in the same way, when non-metals like which are found to be the negatively charged particles, so in such cases as we know, like metals are the electron donors. They have good what you say like found, they are ready to give off the electrons. They have the capacity of losing an electron. So during which you can find when these metals, when they are found to be electropositive in nature and being positively charged ions, they have tendency to give electrons, and those electrons are gained by our negatively charged particles which are found to be as electronegative in nature, and they has the tendency and capacity of taking those electrons. So this losing and gaining of electrons takes place until and unless an atom is said to be stable, because here stability of atom is most important. So when it is going to be stable, or when it's going to be until and unless when they are going to lose the electrons or when they are going to gain the electrons, in order to be stable, that concept we have to learn, and where we basically find there exists some strong forces of attraction between these bonds whichever takes place or between these atoms during losing and gaining of electrons. Then same way the force, as I was saying you, because there should be some forces which are acting or which may act between any two atoms or group of atoms that results in the formation of a stable entity, a stable compound which is said to be electrically neutral. So that stable entity where we are trying to find or trying to associate this group of atoms, or where we can say it as the force between any two atoms or a group of atoms that result in the formation of a stable entity is called chemical bond. So you can see an example here, like a bond that holds two or more atoms together. So you can see this is one atom, the first atom, and this is your second atom. So you can say like these two different atoms are of the same entity or of the same atom. So when this one atom and the second other atom, when they are being grouped together, or which holds these two or more atoms together, can you see these arrows are giving us very clear indication that they are holded, or they have been held by some forces. So some strong forces which allows these atoms to hold together, which allow them to hold together, or which makes them to bind together and to give you a bond associated compound or that molecule. Because this group of atoms whichever are grouping together, or when this group of atoms are joined together, or when they are grouped together, they result a particular molecule, and that resultant entity which we are calling as a molecule, it's a new substance. So that new substance whichever is formed, which allows the sum of the forces which is allowing, or the forces which allows this group of atoms which are said to be bonded, or those entities which tries to hold these atoms together, is basically called as a chemical bond. Yes. The next we can go to the other concept, like based on which we need to find. So as we are saying, like this group of atoms are hold together with some sort of forces, and that forces which involves or which are indulged in the formation of this bonding, we call it as a chemical bond. So now how to know, like the as we said, these ions whichever are positively charged particles and negatively charged particles ions, they have the tendency of losing and gaining electrons. So in which cases we need to know, like which of the following atom loses the electron or gains the electron in order to be stable, that also we need to know here. To know that concept here, we need to basically know as a concept of our valence electrons. So as you know very well, the outermost shell of an atom is called as valence shell, and the electrons whichever are present in that particular valence shell, which we say is the outermost shell, is called as valence electrons. So you know basically, now I took an example. Now this, as you know, this is the nucleus, and you can see now this is the first K shell, the next comes your L shell and the M shell. So as per your Bose model and as per our valency concept also in your earlier classes in 9th, you have learnt it like the available, because whenever the losing or gaining of electrons mostly takes place, or it depends purely on number of available valence electrons. So first we need to know, like each and every atom contains how many number of valence electrons in its outermost shell. So here for this particular X atom, now you can see this is the first K shell, and this L shell is acting as the outermost shell. Now this is called as the this is basically which we call it as outermost shell. And this outermost shell, so whatever the electrons whichever you find in the outermost shell, can you see this is the outermost shell. So whatever the electrons present whichever are present in the outermost shell are called as valence electrons. They are called as valence electrons. As you know, electrons are denoted by E minus. So basically here we are trying to find like the number of available electrons in the outermost shell are defined as valence electrons. So based on this number of valence electrons, we are going to find and trying to give you the what we say, like we come to a conclusion where we are trying to ensure an atom to be electrically neutral or stable depending on the number of valence electron. Does a particular atom need to lose it or it need to gain it in order to be stable? So first we should know the concept of this valence electron. So the number of available valence electrons in its outermost shell, that which we call as valence shell, are called as valence electrons. Then in the same way, this whatever the valence electrons whichever we found in any of the atom of an element is depicted in a short form by short form which we call in the short form which we call as Lewis symbols or electron dot structures. The number of available valence electrons which are present in the outermost shell, which we call as valence shell, are represented or they are depicted in the short form by using Lewis symbols, or which we call as even electron dot structure. So, how you are going to represent these valence electrons, which we are calling as Lewis symbols or those electron dot structures, that we need to find here. So, we represent the nucleus and the inner shell of the atom by the symbol of an element, but the electrons which are present in the outermost shell, which are present in the outer shell by dots, or they can be represented by cross marks. So, you can see basically an example. We took an example of a chlorine atom, basically a chlorine atom. So, you can see these are called as the valence electrons of that particular chlorine atom in its outermost shell, or which we call as valence shell. The number of electrons present in the outermost shell or present in the valence shell of chlorine atom can be represented in the form of dots. So, these dots, whatever you find, these dots representation is nothing but these are your valence electrons. These are the valence electrons. Those valence electrons which are present in the outermost shell of that particular atom in its outermost shell or in its outermost orbit. So, those you can represent in form of a dot, or you can also represent in the form of cross also. So, those representations can be with cross, or those can be written in the form of dot also. Means the number of available valence electrons can be represented in form of dots or either in form of cross. So, that we need to find here. Like basically we need to find for each and every atom now. Like we need to know now how many number of valence electrons are available for each and every atom, where we try to represent those number of valence electrons either by dots or either by cross. Yes. So, comes Lewis dot structures. So, we are trying to learn like what are these Lewis dot structures. So, basically to understand this concept, as we know, like we need to first know with the number of available valence electrons in the outermost shell or the valence shell of any of the atom which you are going to take here. In such cases also you need to take care that basically like how you are going to represent. So, because as we learnt, like these Lewis dot structures or the Lewis symbols can be represented in the form of dot or either in the form of cross here. Yes. So, as we can, when we start with argon, because you know the argon is an element which we go with the symbol as Ar. So, it has 8 valence electrons in its outermost shell. So, basically it has outermost, means your outermost shell, or which you also can say as outermost shell, or which we can say as orbit. You can see the valence electrons are filled with 8 electrons. So, basically how you are going to represent it? First you need to write the symbol of the element Ar. As we know, first you need to go with the symbolic representation of that particular element which you are trying to represent their number of available valence electrons in the form of dot or in the form of cross also. And place these valence electrons around the symbol and put 2 dots at a time or 4 dots, as you can see. So, you can see now these are the dots, these are the number of valence electrons. These are nothing but these are the number of valence electrons. So, as we know, like when we took the example of argon, so as we find argon is filled with, found to be with 8 valence electron its outermost shell, isn't it? They have, argon contains 8 valence electron in its outermost orbit or outermost shell, in its outermost shell. So, that representation, the number of available valence electron need to be represented in the form of a pair like 2 dots. Can you see? Now, this is one pair of dots, this is second pair, third pair and 4 pair of dots. So, that is the reason it is given here, like you need to put the 2 dots at a time on each of the 4 sides of the symbol of the element till all are used up. Means as per the available valence electrons, whichever you are going to find in each of these elements need to be represented in a form of dots or either in form of cross also. So, the same element inside we can represent in the form of a cross also. Means again you need to show that the cross R need to be again placed 2 at a time as per the available valence electrons, because this available valence electrons only will give us the count of availability, means the chances of gaining or losing electrons, and which depends on which we are going to find the available orbital, the available electrons left out for bonding, and in such cases losing and gaining of electrons need to take place in order to see that the atom need to be electrically neutral or stable by forming this bond. Then next you can see, even you can also use cross mark for the electrons. So you can see the same dot representation, means the valence electrons can be represented in the form of dot, either in the form of cross also. Suppose if you take an example of sodium also. So when you go for electronic configuration, as per electronic configuration of sodium, so as you know the atomic number of sodium is found to be 11. So when you write the configuration 1s2, s2, 2p6, 3s1. So you can find this one valence electron found in case of sodium atom in its outermost shell. So you can represent that one valence electron either in the form of a dot, or even you can represent that one valence electron in the form of cross also. So during this we can find the different the number of available valence electron for each different atoms depending upon their outermost shell or in their outermost orbit, where we are trying to define and trying to find those number of valence electrons which we are trying to represent in the form of Lewis dot structures. If you go for example, in the same case, if you go for magnesium, so as you know magnesium is with atomic number 12. So when you write its configuration again 1s2, 2s2, 2p6, 3s2. Again you can find the number of valence electrons in case of magnesium atom in its valence shell is found to be 2. So when you are trying to represent again the magnesium, so basically you are going to represent with 2 crosses, with 2 cross, or either with 2 dots. So this is the way we try to represent the number of available valence electrons for each atom. Yes. The next comes like we need to go for some of the examples like Lewis dot structures of atoms of noble gases. So you can find like in case of noble gases, like which you already know in our when you were learning periodic classification of elements, which we call as 18th group elements. We can say in a noble gases as 18th group elements or 0 group elements, because as they are present in 18th group and because of the number of valence electrons found in their outermost shell of these inert gases or in noble gases, you find to be 0. There are no available valence electron because their outermost shell is filled with the 8 electrons, which we are going to learn as called octet rule. Because like as per the rule, we know like each and every entity, whenever it undergoes the bonding or when they try to lose or gain the electrons, you need to see that the number of available valence electrons in their outermost shell need to be filled with 8 electrons. So once if they have been filled with or found with 8 valence electrons, that's nothing 8 electrons in their outermost shell, then you can say those particular atom is electrically neutral and thus it's stable. So in case of noble gases, you can find that in all of the cases, like whatever the noble gases or which we say as 18th group elements, we call them as 0 group elements also, because of no number of valence electrons. We find there is no number of valence electrons left for bonding, either for losing or gaining. Why? Because you can find the number of valence electrons in case of noble gases like neon, argon, krypton, xenon and radon are filled with 8 valence electrons. You can find the outermost shell of these elements, which you call as noble gases, are filled with 8 valence electrons. Filled with 8 valence electrons. Filled with the number of 8 valence electrons, and except in the case of helium, because when you go for helium's helium number of valence electrons, as per your K shell, as you know, the K shell accommodates the maximum of number of 2 electrons. So as you know, like helium falls according to its configuration, it falls in K shell. So you can find the K shell is filled with the 2 electrons. So basically when you go for the other elements like neon, you can see these are filled with 8. Again argon also you can see it's filled with 8 valence electrons. When you go for krypton, it's filled with 8 valence electrons. When you go for xenon, so this is the reason you can find each and every element or those noble gases which are situated or which are being located in our 18th group in our periodic table are found to be filled with 8 valence electrons in their outermost shell or in outermost orbit, and that's the reason we also call them as zero group elements, except helium, which you can find it's filled with only 2 electrons. Its inner shell as which is as inner shell as K shell, which we found where helium configuration falls. And next comes the other elements representation with the available valence electrons by going with the Lewis dot structures. So you can find here the different elements. When you start with your regular atomic number, when you start representing your and writing your elements as per atomic numbers, as you know, like when you go for first atomic number element hydrogen, you can find the total electrons 1 and the configuration, as you can see, it's 1s1 and available valence electrons is 1. So you are representing it with only 1 dot, or even also represent in the form of cross also. Same way if you go for helium, you can find helium's electrons 2, as you can see. In case of noble gases also, an electronic configuration you can find it's 1s2. The number of valence electrons are found to be 2 and representing in this way. Then go for lithium, you can see the configuration 2 plus 1, so this 1 valence electron, you can see there's only 1 dot, or you can go with 1 cross. Beryllium, you can find 2 valence electron in its outermost shell as per the configuration 1s2 2s2, and you can find there's a 2 valence electrons which we are representing in the form of a dot. Same way for boron, you can find 4 and plus 1, so you can find the outermost shell, because this is as per your configuration as per shells. K shell is filled and you can see it's left with the L, means L shell is acting as the outermost shell or the outermost orbit for boron, left with 3 valence electron 2 plus 1, so you can see 3 dots which we represent in the form of dot, or you can represent in the form of cross also. Then when you go for carbon, you can find even the carbon, the first K, the next L shell, it's filled with 4, 2 plus 2, the 4 valence electrons, and those 4 valence electrons are represented in the form of dots, or even you can, if you are writing it, you can write in the form of cross also. So this is how basically, this is the first 1 to 6 set of elements which we write according to their atomic numbers, a way of representing those elements with their atomic numbers, with the symbols, with their electronic configuration. Depending on the electronic configuration, the number of available valence electrons as per the shells K, L, M, N, which need to be filled and satisfied, according to which we are trying to find and account for the number of available valence electrons in each elements and trying to represent them with the Lewis dot structures in the form of dots or either in the form of cross also. And you can go for other elements also which you basically have for nitrogen, oxygen, fluorine, neon. In the same way you can go for the other representation, and even we have done with some cases of in examples where we are trying to show the examples of sodium, even magnesium. So those sort of examples also you can consider when you are trying to represent your Lewis dot structures to show the number of available valence electrons. So the same thing we are trying to show here also, because you can go get this type of questions like try to just where you need to explain or try to show only the representing these particular elements in the form of atoms, in where you are trying to represent the number of available valence electrons in the form of dot structures or cross structures, which you call as Lewis dot structures. Yes. The next, even you can even see the Lewis symbols as per your periodic table. So as you know, like as per our numerical notation and as per our Roman notation, like as you know, the periodic table contains horizontal rows, 7 horizontal rows called as periods, and 8 vertical columns, or which are been modified as 18 vertical columns, which we call groups. So here also you can try to find the representation of these what we say, the valence electrons, the number of valence electrons available for each group which are represented in the form of a dot or a cross here. So basically when you go for the first group here, you can find in case of first group, as it's, you can see the number of valence electron, the group number itself gives you will give you the number of valence electrons, because already like we learned some of the properties, some of the periodic properties which we come across, during which we found like the particular elements whichever are situated are found to be existing in that group, they are designated or they are been placed according to their number of valence electrons, because how many number of valence electrons are found in their outermost shell of that particular atom, those elements are placed with the common group number which indicates the number of valence electrons, or which also says only valence or that valency, where if we can find the overall the valence electrons in that group to be only with that particular valency left out with those valence electrons. So in the case of first group, you can see here the number of valence electrons are found to be 1 in their outermost shell. If we go for the example for hydrogen, lithium, sodium, potassium, in the same way when you go for second group, as you can see the second group itself indicates that they contain, the elements contain 2 electrons, 2 valence electrons. So you can find in the case of beryllium, magnesium, calcium, so there are only 2 valence electrons. In the same when you go for third group, again in third group, as you can see the number of valence electrons, 3 valence electrons. The group number gives you the confirmation. So you can find there are 3 valence electrons. The same way when you go for fourth group, you can see 4 valence electrons. Basically where you can find there are 4 valence electrons in that group. And generally when you start again moving towards from left to right, when you have been moving from right to left of the table, you can generally find first your valency, that's not the number of valence electron first increases, then they start decreasing. So when you start again from the fifth group onwards, you can find the valence electron basically decreases from 3 to 1, 0. Means here again you will find there are 3 valence electrons. Here there are 2, you can find it's 2 valence electrons. Here only 1 valence electron in this group, and here no valence electrons only, no valence electrons. So as you can first see, generally the number of valence electrons increases up to 4, and generally from here again you can see there is a gradual decrease in the number of available valence electrons, or which we also says valence, or which is as valency, where you can see basically there is a decrease in the number of available valence electrons. So when basically when you start again, you can see the fifth group, you can see there is only 3 valence electrons. When you go for the example of nitrogen, you can find there are only 3 valence electrons available in its outermost shell, or which is as outermost orbit. And same way for sixth group, you can see there are only 2 valence electrons. If you take the example of sulfur also, in this case phosphorus 3. Again when you go for seventh group, which we have 17th group, so basically you can find this is your 14th group, again this is 15th, 16th group, 17th group and 18th group as per your Arabic notation, as per your modified period, as per your modern periodic table, the modifications which were done by Moseley. This is 13th group, and these are basically your first and second groups. Basically we consider S block and P block elements, where we basically find there's a losing and gaining of electrons by our theory, which was laid forward and put forward by Lewis and Cousel theory, where we are going to find like how this losing and gaining of electron takes place as per the available valence electrons, as per those elements which are located in the periodic table. As per those, we are going to find their the way have been presented, and the way they have been found with the number of valence electrons which we need to count and take into consideration. Again when you go for the seventh group, you can find there is only 1 valence electron in case of fluorine, chlorine, even the other halogens which we have, which we basically say 17th group as halogens, chlorine, fluorine, bromine, iodine, and you can find those, all these elements are found to be with 1 valence electron in their outermost shell or orbit. In the same when you go for 8th group, which we call as noble gases, there is no valence electron. You can see these all are paired up with and filled with 8 electrons in their outermost shell, which gives us a clear indication that they are stable and they are conformably electrical neutral. They neither lose or gain electrons, and they doesn't involve in any kind of bonding here. Okay. So this concept has been given clear indication. Gives us indication about the number of available valence electrons per each group, gives us an indication, and based on that only we try to decide its valency and the capacity and capability of combining or losing or gaining of electrons also. The next comes like, as we've been going on saying that an atom need to be stable depending upon the available valence electrons, and there we try to say that they should be the 8 valence electrons, means the number of available valence electrons in the outermost shell of each and every atom. If they need to be stable, we need to see that they are filled with the 8 valence electrons. So if they are not been filled with 8 valence electrons in the outermost shell, in such cases they need to gain or they need to give out the electrons so that the atom need to be stable or electrically neutral by forming bonds here. So because of that reason, in the concept we are going to introduce a rule called Octet Rule. So let's see what is the Octet Rule, which gives us the clear indication and confirmation of each and every atom of the element need to be filled with their outermost shell with 8 electrons, called as Octet Rule. In the word itself, octet. In the word itself, octet means here it gives you 8 electrons, means 8 valence electrons, which we say that too its valence electrons, not only the 8 electrons. We are trying to say those 8 valence electrons in their outermost shell or in their outermost orbit, which need to be satisfied. Once need to satisfy that, in order to find an atom need to be stable, you need to fill its valence electrons with 8 electrons, which we call as Octet Rule here. So basically, as we can state, it can be stated as the atoms of elements tend to undergo chemical changes. Chemical changes in the sense either they give the electron or they take the electron, means losing and gaining of electrons basically takes place here, which basically takes place where chemical changes that help to leave their atoms with the 8 outer shell electrons, which we say as valence electrons. And Lewis depicted, as we have been learning the Lewis dot structures, during which Lewis depicted the atoms in terms of positively charged, called as kernel, where we basically say kernel is the nucleus and all the electrons in the atom except the outermost shell, outermost electrons that could be accommodate a maximum of 8 electrons. So here we are very much particular with the outermost shell, because here we are going to go with only the case, means we are going to consider the outermost shell which need to be filled with the 8 electrons in order to attain stability, because during which the chemical changes, the losing or gaining whichever takes place in an atom need to satisfy and need to be stable by accommodating by 8 electrons in their outermost shell. So you can see the example. We took a magnesium atom here. So basically, as per atomic number magnesium, atomic number 12, when we write the configuration, you can know it's 2s2, 2s2, 2p6 and it's 3s2. So you can see the number of valence electrons which we found in case of magnesium are with 2. Can you see now? It's overall, as you know, this is your protons, because nucleus is due to its protons and neutrons. So basically, as you know, it's 12 protons, isn't it? So here, like the number of electrons which you can find in its outermost shell, you can see now this is your K shell, this is L shell. When you come to M shell, so because as you know, K shell accommodates the 2 electrons which we find, and basically when you go for L shell, which accommodates the 8 electrons, when you count you can see it's 8. Then the next remaining 2 electrons which are found in its outermost shell, this M shell, which acts as an outermost shell for your magnesium atom, try to give out these 2 electrons. So once these 2 electrons are given out by magnesium, then it forms or it acquires a positive charge, because as you know, like magnesium being electropositive tries to give out the electron, has a tendency to give off electrons, lose the electrons as per the available valence electrons in its outermost shell is already found to be filled with 8 electrons. So the remaining left out, those 2 electrons are basically given out in order to be stable, and thus it forms a positive charge as it's being electropositive in nature. And then you can see, then basically they are left with 10 electrons. Basically they were found to be with 12 electrons. As 2 electrons are given out, by losing those 2 electrons, it tries to be stable and attempts and try to find with 10 electrons, one being in K shell with 2 electrons and L with being 8 electrons. So in this way we try to find the stability of an atom. Means each and every atom tries to attain stability either by losing or gaining of electrons based on the pure concept of octet rule, because each and every atom need to satisfy its what you say, they need to be stable or need to be electrically neutral by just attaining the 8 electrons in its outermost shell or in outermost orbit, which we call as valence electron. So this is how, children, we have the octet rule gives us the idea for forming the multiple bonds, which gives rise to the concept of our chemical bonding, where the losing and gaining of electrons which basically takes place. So this is how we started our chapter chemical bonding with basic introduction, and we have learned the Lewis dot structures which try to represent the number of valence electrons per each atom, and even we learned the concept of octet rule. In our next class we are going to learn the electrovalence theory, which was proposed by Poisson and Lewis, where they were trying to explain the concept of losing and gaining of electrons and try to be stable as per our periodic classification elements, which have been grouped up and placed, and based on which we try to form the different bondings which we are going to learn in our chapter, like chemical bondings like ionic bonds, covalent bond, basic bondings, and with their structures, with the representation, with some of the examples. So till then, keep watching Classroom TV and visit to our website classroomtv.in for latest videos, materials, practice papers. Each and every material you are going to get it when you are logging to our website. Until then, go through the content and keep watching Classroom TV till next class.